right. Thank you, everyone, for joining our Gen AI AMA panel. We have a panel of experts from the Databricks team here that I'm very excited to ask some questions from. And if we have time at the end, would love to have some questions from the audience. So from left to right, we have Yinxi Zhang, a staff data scientist and a rock star at implementing everything LLM ops. We have Eric Peter, our senior staff PM for everything RAG agents. And if you have any questions about our new agents framework, Eric's the guy. We have Xing, who leads our ML research and engineering team. And we have Layla Yang, a principal solution architect focused on the CMV vertical. That's all right.
Lead solution architect. Nice to meet you.
All right. So to kick off the panel, I'd love to start with you, Layla, actually. Why are the majority of Gen AI applications still in the POC phase?
Ooh, that's a great question. By working with our customer, we realize Gen AI and LLM large language model is actually a pretty exotic breed, very different, well, compared to whatever that we learn, like statistical learning and statistical machine learning, traditional machine learning models. So I think that requires a lot of people learn complete new skills from a different paradigms. So that's number one. And secondly, while everybody clearly see the value of the large language model, what it can do for you, but big enterprises still lots of debates on, around ethical use of AIs and such as bias and privacies and compliances. So I think, that's what makes lots of companies are still, in the POC phase and not stepping or jump into the minefield, so to speak.
Thank you, Layla. And then follow-up question for Yinxi on that. So in the POC phase, most of the focus is on business value. But when you try to take things into production, the emphasis focuses on cost and governance. So what are some of the major hurdles to getting these applications into production?
Sure. From my experience, I feel like most of the use case in the end become a risk management. So it's risk management from all kinds of perspective. How do you manage your risk of your data governance and data security? And then how do you risk management your quality of your deployed models? So on the data governance and API governance side, LLM is quite different from traditional ML. Your interaction with LLM usually comes from API interaction rather than from model in your local environment. So people are concerned about how do I manage cost and how do I governance my usage across the enterprise. So that's one type of hurdle. I think that could be much better if you use a unified platform and unified service. On the quality side, I think users are concerned about risk that might bring if my LLM isn't performing well. So how do we make sure the model can have certain level of guardrail and being able to provide user feedback to that? So I think one of the other hurdle is evaluation, because it's really hard to craft evaluation data set, and people are concerned, I don't know how to evaluate this, so I'm not sure whether I can put it into production.
Thank you, Yinxi. You raised a number of really good problems. Eric, do we have any solutions from the product side for some of these problems Yinxi just posed?
I feel like most panels I sit on, I don't get such easy questions. Yes. I think today, if folks have seen the keynote and seen some of the talks, we announced a handful of products actually that help across the suite of essentially the core problem of quality. So how do I deliver an application that's actually high quality? How do I do that in a way that's safe and governed? And so the capabilities that we announced today, first is the agent framework, kind of an end-to-end suite of tools integrated with MLflow and the rest of the lakehouse for building, tracking, logging, tracing, and deploying agents, whether those are RAG agents, whether those are agents that use different tools on your platform. Coupled with that agent framework, we've announced agent evaluation, which is a suite of AI-assisted judges, again, tightly integrated with the lakehouse and MLflow that essentially can intelligently tell you, based on your evaluation set, well, which ones are good, which ones are bad, and what is the root cause of the quality problems. Probably like, well, that's great, but I don't have that evaluation set. We also released today the review application, which is a tool for collecting feedback and input from your business stakeholders, tagged with exactly what happened inside the LLM application so that you can then go create that evaluation set all inside the platform. So those are just a few. We released a bunch of other cool things today, but those are the ones I'd probably call out right now.
Amazing. And Xing, did you have anything to add on top of that from the research side within the evaluation space?
Yeah, actually a little bit. So, the fascinating thing in the research space right now is it's easy to look at all these models coming out with, nice numbers on MMLU and human eval and so on and so forth, and these sort of benchmarks that are just kind of accepted at face value. But when you actually look into what's happening in those benchmarks, it's typically not stuff that's very relevant to us. And I'll just tell you a very funny inside story. So, we were working on text to SQL capabilities in the research team. And we actually, the team did an amazing job using synthetic data techniques and other techniques. And we actually beat GPT-4 on one of the leading benchmarks. And I won't say which benchmark it is, but on one of the popular benchmarks for text to SQL, we made DBRX better than GPT-4. Actually, we thought about talking about it here, decided not to. Because what happened is when we looked at what was in that benchmark, it turned out that the eval was just kind of wrong sometimes. There were cases where we're like, oh, I think GPT-4 gave kind of a reasonable answer, but the eval is very suspect. And so that kind of actually led us back to the drawing board to say, actually, the problem here is not just oh, can we make models good based on the evals out there today, but it's actually that, we don't even know how to measure these things. And so actually on the research side, we're kind of going back to step one of how do we measure these LLMs and AI systems in ways that are actually useful and relevant. And so, I would say stay tuned in the next few months for more on that.
I can't emphasize that enough. There's this concept of evaluation-driven development. You have some evaluation set and you measure yourself against it. It's not a new concept. It's been around for, I don't know how many ever years since we've been working on ML. But I think now that we have essentially all of the software engineering community building generative AI applications, it's important to think about this concept. And when you're building a software application and you test it, you're like, okay, I made an improvement. Guess what? That improvement will continue to work over time. With generative AI, or frankly with any ML application, you need to have the evaluation set, which is the equivalent of unit tests. And so having a good evaluation set, if you don't invest in that up front, it's kind of I don't what's a good analogy here. You're trying to improve something, but you have no idea what's actually happening or how to measure that improvement. So you might as well just run around in circles if you don't have an evaluation set.
Does that continuous evaluation apply to evaluating judges too? So for some of the evaluations, we're using LM as judges, but you also want to keep evaluating and calibrating your LM judges.
You absolutely have to. And I think Xing can speak up on this too, but a lot of the work we're doing with the research team is around how do you get these LLM judge models to actually calibrate. And the interesting challenge is the naive version of the solution of calibrating your LLM judges. Okay, I've got a bunch of human labels. Let's make it the same. If you look deeper in these, and again, always look at the data, because you'll be surprised every time you look at the data, you'll be like, oh, that's interesting. Humans don't even agree. So you ask 3 humans to say, hey, is the answer to how do I use SQL inside Databricks SQL? How do I do it? Ask 3, of the very intelligent folks on our field engineering team, you'll get 3 slightly different answers. And so it's really important that when you think about, calibrating your evaluation set, you think through that, but then also, right, if you're going to go calibrate your LLM judge, which is an absolutely critical step that you have to do. And by the way, our product helps you with if you're not sure how to do it. You also need to make sure that you're calibrating it against the human that you trust, not just 3 random amounts. I don't know, Xing, if you want to add anything on top of that.
I think you covered it. So, yeah.
I just have this is exactly why lots of projects are still in the POC phase. I'm curious. Please raise your hand. What we discussed, is it related to everybody's work? And yeah, perfect. Yeah.
So actually, because you all mentioned GPT-4 and comparisons there, pretty much every customer that I speak with says, I want to train my own model that outperforms GPT-4. What advice do you have when customers have those requests? How do you typically handle those?
Build an evaluation set.
I will go.
Yeah.
I will give a shot. Fine tune a small model. Yeah, that's actually pretty effective. That we work with a bunch of big enterprise customers, so we saw really good results. And because utilize your proprietary data that's most valuable and most relate to the specific task, and you can outperform GPT-4 for specific tasks. You don't need your model to know everything, know history, know how to reasoning or do math, and but yeah, just to fine tune a small model is probably a good first step.
Yeah, and I would just add, on the research side, the first question we always ask is, how do you know if your model is better than GPT-4? So it kind of goes back to, again, starting from eval. I think the thing we're always worried about is someone comes to us to train a model, big or small, and say, okay, how do you know if this worked? Like, how are we going to know if this worked? And sometimes the customer says, I'm not sure, and that's kind of the scariest thing for us is if you're, number one is like, can you define your success criteria in a meaningful way? And if you can, then it becomes possible to kind of try different techniques. Typically we recommend starting small and kind of working your way up. But number one is just understanding which hill you're even climbing, basically.
I mean, the analogy here is if you're running a company or the CEO and you tell your organization, team, we need to go from 2 million of ARR this year to 10 million next year, and the finance team doesn't have a way to count the ARR. How are you going to know if you succeeded? Same idea here. Everyone's like, no, we definitely sold all that stuff. Like, I guarantee you we're at 10 right now. But unless you can measure it, you're not going to be able to actually know if that model is, even if GPT-4 is doing a good job at your task.
Yeah, totally agree with what the rest of the panels are saying. In the end, it's still your business problem. Put your GenAI into business context and having proper and deterministic metrics to evaluate your GenAI applications.
And so, Xing, next question for you. So I know that there's some customers that are hesitant to fine-tune models because they continue to see the progress both in the proprietary model space and in the open model space. And if they fine-tune today, maybe there's an open model that outperforms the one that they fine-tune today. What advice do you have for customers that are hesitant to do fine-tuning, but the current models don't suit their needs?
Yeah, that's a good question. I mean, I would say, look, we're kind of all in a open science research environment now, whether you want to be or not, to some extent. And so, we always approach it with the mindset of experimentation. So obviously, experimentation can be expensive depending on how big or small you want to, go with fine tuning. But it's important to sort of start and learn, right? Like in some ways, our chief scientist likes to say, LLMs have made all of us empiricists to some extent, right? Like it's not about the theory anymore. Back in my day when I learned about machine learning, it was convex optimization and whatever. None of that matters anymore. Now it's like just, start climbing the hill and see where it takes you. And so there's some amount of just like, understanding the setup where you can understand your problem. That's the most important thing. And then probably the main advice I would give is just, start small, right? Start small, try to learn about what works, start with prompting, many shot examples, then, try some fine tuning. If fine tuning throws the model off too much, try LoRa. We've shown it's a good regularizer. But there's different experiments you can run and try. But there, at this point, like there's no sort of one size fits all recipe. Like you really do have to experiment with your use case to understand what works. And our goal is to make that experimentation loop faster and easier, because that's sort of what you have to do right now in this space.
I would add, like, if the situation you find yourself in is, hey, like none of the open source, none of the proprietary models are good enough quality for my use case, and you're like, hey, I'm hesitant to fine tune. I think the way I would think about it is, does the business case make sense? Is there enough value here to be created? And then you can think about, okay, well, does it make sense to try out the fine tuning? And yeah, we make fine tuning really easy. We make it really easy. But if you don't have the business value there, then there's no point in even thinking about it.
And since you mentioned traditional ML requiring convex optimization, et cetera, with this transformation into generative AI, what are some of the differences of productionizing ML systems versus Gen AI applications?
Yeah, so that one's really interesting. I think what's happening is higher level issues I find are actually very consistent between classical ML and LLMs. Like, just to give you an example, the experimentation loop. In the classical world, one of the reasons ML flow was so popular is it allowed you to organize and iterate quickly on your experiments. I mean, some of you probably remember, 15 years ago, I would end up with a pile of like 100 different CSV docs in a folder somewhere and like each had like a different name, like this underscore date underscore v4. But like LLMs, what's interesting is, right now people are just doing POCs, but as you scale up the experimentation, we believe you're going to run into the same issues. We already see people running into the same issues of like, how do you experiment at scale and do many, many iterations on LLMs? It's not just like, oh, let me change my prompt once. It becomes like, how do I actually optimize the prompting? How do I do many shot learning? How do I do, fine tuning with prompting, with a retrieval step? Oh, but what happens if I ablate the retrieval step? Is that actually better or worse? But now I have, re-rankers, and what happens when I add the re-ranker? And you kind of end up with this combinatorial explosion of possible ways to experiment with your LLM setup. But the high-level problem is the same problem we had before, right? Which is, how do you do experimentation and have the ability to introspect what's going on to be able to take the next step efficiently? That high-level problem kind of remains the same. So that's kind of one thought that's coming to us.
As much difference as we have between traditional ML and Gen AI, I think a lot of the toolings and framework we have for traditional ML ops can still be applied to LLM ops or even Gen AI ops because they share the similarities too. And in terms of difference, I feel like technically it's mainly in the model and in the data, right? In the model side, how we interact with LLMs and how the LLM chaining looks like is a little bit different from traditional MLs. But in the end, traditional ML have a lot of ensemble models too, and people build complicated ML systems. So still apply the same methodology, strategy, and framework to make sure you can productionize your Gen AI applications.
And then for any of the panelists brave enough to answer this question, any predictions for the future in Gen AI? And we'll say future is 1 to 2 years out.
I will go first. I'm a firm believer that AI for everything. AI will embed it in all the product and in our everyday lives and augment our human ability. That's my bet.
So I guess we can go down the line here.
Buying myself time to think about my
there you go. Yes. I really feel like there's an analogous path where, if you look at machine learning 15 years ago, what happened was machine learning became embedded in these systems. So I'll call them like machine learning ML-driven systems, let's say. Like, Google is like a massive ML-driven system with many, many places where machine learning is used for decisions. But the system is not just one model, right? The system is like many heuristics and products and business logic. I think we'll find LLMs used more and more that way, where they're embedded into systems. Now, I think the big difference is the curve of like who gets to build those systems is now shifted, where back 15 years ago, it was like you had to be Google to build this kind of system. Now, everyone here at the conference can do it, right? Like you don't need to be a machine learning expert. You don't have to go hire your team of data scientists. Like you can be an analyst, you can be a general SWE, software engineer. You can go build your LLM-driven system. I think that's the big difference is, I think we're going to see LLM-driven systems, but at just like way more massive scale than we saw ML-driven systems in the past.
Yeah, I mean, I would 100% agree with the systems trend. I think it's just emerging and it's around. That's what's going to happen. As definitive as I can be about the future. The other thing I would add is I think we're going to see a range of specific models come out. And so like folks are not going to be using GPT-4 or whatever the biggest model is for every task in their business. They're going to start using billion parameter models. They're going to start using 7 billion parameter models. And they're going to have those tuned for specific use cases. And the reason that's possible is because of the systems concept, where if all of a sudden you can say, okay, I need a model that specifically says, hey, this question is on topic or not on topic. You can actually train a pretty small model and get effective results there. Whereas if you're asking, a generic big model to do that, yeah, like you need a decent sized model to be able to say, is it on topic for these 6 topics and these other topics? And so I think we're going to see that trend. I think we're already seeing it towards smaller language models embedded in systems with a few large models kind of, embedded throughout that system. Don't make any stock purchases based on my advice.
I think I share a similar view. I believe in large, powerful genetic models too, but I'm a true believer of data. So everything relies on your data. I think I would love to see enterprise making best use of their own data to create, to find insights and values from data with powerful models. Either it's smaller, fine-tuned ones or generic ones, but still all the values lies in your own data.
100% of companies will have a lake house on Databricks.
In 1 to 2 years. Well, we're at
Sure
time.
hope so.
We're at time right now. I just want to take a moment to thank all of our amazing panelists for joining today. And if you have any questions, feel free to ask us after the session. Thank you.
Thanks, everyone.
Thanks,
Thank
everyone.
you. Bye, everyone.
Thank